All right, welcome. This is going to be part two for finding terminal points, and we're going to look at the remaining quadrants. So in the previous part, we went through and we found all of the ordered pairs on the circle for the special angles, but we only looked at the first quadrant. And here's the reason why we only looked at the first quadrant. Um, if you were to look at this circle right here, and I told you to mark um, where theta was, let's say 3 pi over 4. Well, you could look at the picture that we've done before. You could cut the circle up into slices. I'm going to go ahead and put this in. 3 pi over 4 is here. It's in the second quadrant, specifically right here. And I want you to look at 3 pi over 4 here. And I want you to notice that this angle in degrees is 135 degrees. In other words, if I asked you to draw a right triangle here with 135 so that we could find sine of 3 pi over 4 using my ratios, opposite over hypotenuse, we couldn't do it, right? There is no right triangle that has 135 as a degree measure because in a right triangle, the other two angles has to be less than 90. It's impossible. And so this is why the unit circle is so important because I can't solve this problem sine of 3 pi over 4 using the opposite over hypotenuse. I can't do it because this isn't a right triangle for 135 degrees. Instead, the unit circle will allow me to solve for this, and it's actually going to be a really, really similar process to what we've done before. If you look at what I have drawn so far, um, you may look at it and be like, okay, well, it is possible to actually create a right triangle from this. If I still keep this as my terminal side and this having a length of 1, and look at this as my hypotenuse, there is a way to draw a triangle here. And the way that we're going to draw it, and this is where you need to be very, very, very consistent, is that this triangle is going to be drawn with the right angle always on the x-axis. And part of the reason is consistency. I'll kind of show you this in a minute with another example. But for now, I want you to notice we now have a new right triangle here for 3 pi over 4. Specifically though, what is the angle here on the inside? Because I'm not going to use 135. Notice 135 is on the outside of the triangle. I need to figure out what is that so I can see what kind of angle and stuff that I have. All right, so how do I find that? Well, one way to find it is that the question mark plus 135 degrees has to be equal to 180. And notice again that if I travel 135 and then I travel this remaining slice, we have created a straight line which is worth 180. That's why I can write this equation and represent this equation that way, or this problem that way. And so I can solve for my question mark. So if I go through and I subtract 135, you'll see that the missing angle here is 45, which is pretty fascinating because this then is a special triangle. This is a 45, 45, 90. And like we've done before, if I know the hypotenuse has to be 1, that means this side is root 2 over 2, and this side is root 2 over 2. We know that that has to be the piece. And then I can find the coordinate for this point for 3 pi over 4, because notice I'm traveling root 2 over 2 to the left and root 2 over 2 up. And that word to the left is really, really important because I am in quadrant 2, and all of my x values over here are negative because we're traveling to the left of 0. So when I'm actually drawing out this triangle, we have to be very, very careful that we understand that this is technically negative because of where the triangle is placed. And this is a little bit different from how we looked at before, where I said the side of a triangle can't be negative. And It's really because this triangle that we're looking at is known as a reference. And I'm going to talk about this a little bit more in a minute. All right, so let's go ahead and finish this ordered pair. So my x-coordinate is negative root 2 over 2. My y-coordinate is root 2 over 2. We have the ordered pair now for 3 pi over 4 and its location in quadrant 2. All right, and so now I want to kind of go back and I want to talk about this idea here of a reference. 45 degrees that we got here, or say pi over 4, this is known as my reference angle. The reason why it's called a reference angle, and if you think about just the word reference, like to refer to, notice that to work with 135 degrees or 3 pi over 4, we didn't really use these values, right? What we ended up doing was we found a smaller angle, something that is less than 90 degrees, so I could draw a right triangle, and that's why it's called a reference. We ended up using 45 degrees, or say pi over 4, to go through and find the coordinate. And that's where it gets really, really interesting. It's because for 135 degrees, or 3 pi over 4, my coordinate was root 2 over 2, root 2 over 2, where the first one was negative. Well, what was the coordinate again for pi over 4? So I'm just going to scroll up a little bit. Well, for pi over 4, it's the exact same thing, right? But there's one slight difference. The ordered pair for pi over 4 was root 2 over 2, root 2 over 2. The exact same values for x and y, but the only difference is that for 3 pi over 4, it's negative. Well, why is it negative? Because we're in quadrant 2, right? That's why this matters. It turns out that as you travel past 90 degrees, although we can't keep drawing right triangles for my angles, we can draw a reference triangle for them, and those reference triangles will always refer back to these values we got in the first quadrant. And this is why we went through and did this first. All right, for example, to kind of make my point, I'm going to copy over. I think I can just, I don't think I can. Hopefully I just didn't give you car sickness there. I'm going to copy this over. Let's look at another angle that appears in the second quadrant, one that's not 3 pi over 4. Let's look at, why not? Let's do theta is 2 pi over 3. All right, we know from the unit circle and from working with 2 pi over 3, 2 pi over 3 would sit about right here. This is 2 pi over 3. As a degree measure, if you want to get this rotation, you can convert this. Feel free to convert it if you want practice. I will go ahead and tell you that it is 120 degrees, which means what is my reference angle for 120 degrees? What is the angle that's less than 90 that will help me form my triangle? To find it, notice this is my reference plus 120 has to be 180. So this means my reference is 60 degrees. So I'm going to draw my triangle. It's really, really skinny. That's why I said kind of why not. Let's look at this one. And so I know that this angle here is 60, which means this is a 30, 60, 90, and I can fill out the remaining pieces. The horizontal has to be 1/2. Across from 60 is root 3 over 2, which means I can now do my ordered pairs. This would be negative 1/2 and root 3 over 2. Now again, why does this negative need to be written here in terms of the coordinate? Well, hopefully you're seeing it and you're thinking about it last time. It's because we're in the second quadrant. For my triangle, it's placed to the left of the y-axis, meaning that to go this direction, this is the negative direction on x. So that 1/2 has to be negative here. So the ordered pair for 2 pi over 3 is negative 1/2 root 3 over 2. Well, look at the reference, right? The reference for 2 pi over 3 is pi over 3, right? That's the reference angle because that's what the 60 degrees. And if I look at the coordinate for pi over 3, we'll see that the coordinate is the exact same values. The only difference is the sign. And what I'm going to do is, and you could look at this back in the previous lesson, but what I'm going to do is I'm going to go over here and I'm going to put in that triangle for pi over 3. So if we were to only travel a third, we would be roughly, let's see, you're going to hate this, my triangle's wrong, but I'll keep it, I'll be consistent. So that's about right there. Here, I'll fix it real fast. So my problem was I was actually doing this to scale. So like if you notice, my x-axis here is 1, 2, 3, 4, 5, 6. And I know that if this is supposed to be a half of 6 is 3. Well, look at how far I went. So I made a mistake. So I apologize. Feel free to boo me through the computer screen. I'm gonna go through and fix this. Everything I said is still correct, but my picture was wrong because I can't sketch apparently. Or count. So 1, 2, 3. So that means the point should be about right there for 2 pi over 3 instead. I was just a little bit too vertical. And so here's the appropriate triangle, specifically reference triangle, where this is 60, negative 1/2 root 3 over 2. Hooray for consistency. All right, and so here's the 2 pi over 3, and this would be the appropriate one. So if I draw the reference triangle, this would be the 60 degrees in the first quadrant, which would again be here. And notice that this triangle is a reflection, a mirror of each other. So that means that when I travel 2 pi over 3, the shape of this triangle and the values are the exact same. But because we're on a coordinate system and this is a reflection traveling to the left, the only thing that's going to be different are the signs. And this is true for every special mark on the unit circle and every angle on the unit circle as we travel around. And so I'm going to put up, I'm going to give you a chance to try 5 pi over 6. That's one of the remaining ones we have to do in the second quadrant. And so I'd actually encourage you at this moment, see if you can find the ordered pair for 5 pi over 6. And then we'll finish off the second quadrant, and then I'll see if you can actually do, we'll do the third quadrant together. I'll let you do the fourth quadrant on your own, and then we'll look at the entirety of the circle, and I'll put the overall thing so you can see the final thing. Okay, so attempt, what would it be, what would the ordered pair be for 5 pi over 6? As a hint, see if you can figure out immediately what the reference would be. Oops, almost cheated. What would the reference angle be for this? And then that'll actually help you be really, really quick. All right, so I'm gonna paste my circle back. All right, again, pause the video if you need to. I'm gonna go ahead and the circle's falling apart. It won't move. There we go. There we go. Okay, so I'm gonna go ahead and draw 5 pi over 6. Well, 5 pi over 6 in degrees. Well, 5 pi over 6 first. It sets up about right here. Nailed it. So here's 5 pi over 6. 5 pi over 6 in degrees is 150, which means my reference angle is 30 degrees. but I want to continue trying to think in terms of radians. And so notice that my reference is actually pi over 6. And so from what we've talked about before, this means that for 5 pi over 6, its ordered pair will be the exact same as pi over 6, but the x value should be negative because I'm in quadrant 2 and all x values are negative here. So for pi over 6, its terminal point again was 1/2, or excuse me, I did this last time. Water race. Root 3 over 2, comma 1/2. So that means for 5 pi over 6, I am expecting the ordered pair to be negative root 3 over 2, comma 1/2. That would be my prediction. Let's go through and show that. So again, here in this triangle, this would be a 1. So I'm going to draw my reference triangle. So this is going to come straight down. Right there. Makes my right angle. Here's my overall triangle. Because this is 30, across from 30 is 1/2. The adjacent side is root 3 over 2. And notice this matches, right? We get a negative root 3 over 2 for my x because I'm traveling to the left horizontally, root 3 over 2. My y value is 1/2 because I'm going up. There's my ordered pair, negative root 3 over 2, comma 1/2. Boom. So hopefully you got this. And hopefully this is starting to make sense here in terms of finding the reference. You can find the reference again by doing the degree measure first. So doing 180 minus 150 to get 30 degrees and then doing that conversion. I will show you another connection once I get all of the pieces drawn up here. And so let me go ahead, let's fill in where we're at. We'll put this one in the middle. All right, so far with the unit circle, we've filled out and we've been able to do the entirety of the first quadrant, so 0. We've been able to do, I'll just put in the, I won't put in the spokes, I'll just put in, so this is 1 comma 0. We did here, this is pi over 6, and we got root 3 over 2 comma 1/2. We've got pi over 4, which is roughly about right here, as root 2 over 2, root 2 over 2. We've got here is pi over 3, and this was 1/2 root 3 over 2. We got pi over 2, whose coordinate was 0 comma 1. All right, now we just did the second quadrant, so let me go through and fill in the second quadrant. So let's see, 1, 2, 3. So here is 2 pi over 3, and it has an ordered pair of negative 1/2 root 3 over 2. We have pi over 4, or 3 pi over 4, excuse me, which has an ordered pair of negative root 2 over 2, root 2 over 2. And then I have 5 pi over 6, which was negative root 3 over 2, 1/2. The remaining one is down here at pi. And again, if this is the unit circle, this would be 1 step to the left and no steps up. So the coordinate for pi would be negative 1 comma 0. And so here is the first 2 quadrants. And at this point, I want to kind of start making some guesses here. And so it allows you to kind of make some predictions. And then I'll kind of prove 1 or 2. And then we'll just go ahead and fill in the rest. And I'll leave it as an exercise if you want to draw the triangles just for time. Is when you look at what we have so far, especially when we go outside of the first quadrant. So once I get into values that are here, so like 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, etc. Again, looking at 2 pi over 3, notice that the coordinates, again, match pi over 3. Right? The only difference is the sign, and that's because the triangles are the exact same, meaning for 2 pi over 3, its reference is pi over 3. Well, for 3 pi over 4, its reference is pi over 4 because of the symmetry. For 5 pi over 6, its reference is pi over 6. Again, because of the symmetry, right? If you look at the coordinates, they sit on the same horizontal, which means they have the same x value, and it's the same distance to the 0 origin, which means the x values have to be equal, right? Those coordinates are always going to be the same because we're talking about a circle, right? We're talking about distances, and so they've got to be equal. And so here's kind of my shortcut in terms of finding the reference. It can be as easy as this. Look at the denominators. They match, right? If you have a radian measure that is over 3, then its reference will always be pi over 3, and its coordinate must always be 1/2 comma root 3 over 2. And then you just need to figure out what the signs are, right? If you have something that's over 4, it has to have the exact same coordinate as pi over 4, barring some sign changes. Anything over 6, its reference is pi over 6, and it must have the coordinates root 3 over 2, comma 1/2, barring some sign changes. All right, so just for clarity's sake, and to see if you can make a prediction with this, if I was to go to the next angle, special angle on the circle, we would find that that special angle would be here, and it's listed at 5 pi over 6. All right, well, instead of doing the trigonometry aspect of this based on reference angles, I know that because this denominator is over 6, it must have a reference angle of pi over 6, and its coordinate must match. So I, at the very least, know at 5 pi over 6, its point, the ordered pair, must be root 3 over 2 and 1/2. But what quadrant am I in? And how does this play a role in terms of my coordinates? If I'm in quadrant 3, my x has to be negative, and so does my y. And that's the adjustment we make. And so this is where the efficiency essentially comes in. It essentially says, what angle do you have? What's its reference? After we get its reference and we can get the numbers, then what quadrant are you in? And that'll tell you the sign for x and y. Should they be positive or should they be negative, respectively? All right, so I encourage, as an exercise, if you would like to, draw the triangle for 5 pi over 6, so you can see kind of why that reference is that and why it's pi over 6. I'm going to continue just kind of mapping out the circle and filling in the ordered pairs. As I go through, you can pause the video, or feel free to go back and look at the circle that we constructed in the previous, I think it's the first video of review when we listed out all the special angles going around, and see if you can list the ordered pairs for them. So what I'm going to do is go through now and finish marking out the ordered pairs. So we have 5 pi over 6 in quadrant 3. The next one would be 5 pi over 4. Excuse me, that's right. Ooh, I made a mistake. This isn't 5 pi over 6. You're probably yelling at me right now again through the computer. That was 7 pi over 6, sorry. This one is 5 pi over 4. And its ordered pair would be negative root 2 over 2, comma, negative root 2 over 2. Both coordinates are negative because I'm in quadrant 3, and both coordinates are root 2 over 2 because my reference is over 4. And so I'm going to list the same coordinate as pi over 4, just with the sign change. All right, the next radian measure that's unique, or at least special, is going to be 4 pi over 3. I'm really done at thinking and double checking so I don't make a mistake again. And this coordinate is going to be negative 1/2, negative root 3 over 2. Again, the reference is pi over 3, so I'm going to use the exact same two coordinates, but I'm going to make them negative because I'm in quadrant 3. All right, my next spot is 3 pi over 2. This is 1.5 pi. And my ordered pair is 0, negative 1. Because I'm traveling straight down, I'm not moving left or right, so in the coordinate system, my x must be 0. My y has to be negative 1. All right, now for quadrant 4, I'm going to go ahead and just list the radians and give you a chance. You can pause the video and try to figure out what the ordered pairs are, and then I will just fill in the ordered pairs and see if you got them right. All right, so I'm going to move this reference bar over here just to make some space. Okay, and then I'm just going to list in the radian measures, again, kind of continuing in the clockwise pattern. So this is, or counterclockwise. So this measure right here is 5 pi over 3. The next special angle in the circle is 7 pi over 4. And the last one, is that right? No, I screwed up again. Y'all are going to be really mad at me. It's right there. And then the last one, though, is right here. That one's right. So take that, students. 11 pi over 6. All right, let's go through, see if you can find the ordered pairs for each one of these. I'm going to pause for a sec and not say anything, so that way you can pause the video. And now I'm going to start talking again and go through and list the ordered pairs. So 5 pi over 3 is positive 1/2, negative root 3 over 2. 7 pi over 4 is positive root 2 over 2, negative root 2 over 2. And 11 pi over 6 is positive root 3 over 2, negative 1/2. Notice being in quadrant 4, all of my x values are positive because we're now to the right, but all my y values are negative because we have to go down to get to each one of these coordinates. And so I have quadrant 1, I have quadrant 2, and I have quadrant 3. And we'll talk a little bit more about the quadrants and where they'll play a role in the last kind of objective for this lesson. For now, this is the end. We've got all the terminal points here. We'll talk about how we use this in the next objective. But again, feel free to pause this and kind of study this. For your unit circle, and I'll talk about this in our group session, and you'll see this later. You need to memorize the unit circle. This is everything that you need to memorize. So you need to memorize the radian measures. So going around, you need to know pi over 6, pi over 4, pi over 3, pi over 2, etc. Better than I did, since I screwed them up a couple times. And then you'll need to know their ordered pairs and be able to list them all the way. So you need to know all of these. The remaining one I didn't list is 2 pi. It's the same spot as 0. It's coterminal with that. And so that's why I didn't really list it, but to go ahead and throw it in. Now, you will not have to construct your own circle. I'm going to give you a blank copy. I'll have this attached to this assignment and also put it up on PowerSchool Learning so you can kind of see what you would be given. And then again, I would ask for you to fill out these pieces. A couple tips for filling out the unit circle and memorizing it. You really only need to know for the ordered pairs. You only need to know quadrant 1. As long as you know quadrant 1 and you understand references, then you just need to correct the signs. Remember, it's a mirror image from one another. So going from pi over 3 to 2 pi over 3, same coordinate, x's just need to be negative. So you could essentially mirror all the numbers and then come back and negate the ones that you want to negate. When it comes to memorizing the radian measure, so knowing again where is pi over 6, pi over 4, pi over 3, etc. Here's my one tip for that. In the first quadrant, so we know this is 0, the denominators count down. So 6, 4, 3, 2. In the second quadrant, the denominators count up. 3, 4, 6, pi. They count down. 6, 4, 3, 2. And then they count back up. 3, 4, 6, 2 pi. The numerators, when you are in the first quadrant, the numerators are all 1. In quadrant 2, the numerators are 1 less than the denominator. So notice denominator is 3, the numerator is 2. 4, 3, 6, 5, and we're here at pi. The reason being, is that here in the second quadrant, we are one more slice away from making one whole pie. So if I'm at an over 3, we are 2/3. We're almost there. We're 1/3 shy. 3 pi over 4, we're 1/4 shy. 5 pi over 6, we're 1/6 shy. Which means in quadrant 3, because we have gone past one whole pi, all of these will now be improper, and specifically, we've gone one more slice. So you'll see the numerators are one more than the denominators. 7/6, 5/4, 4/3, 3/2. In quadrant 4, notice we are one shy of going to 2 pi. And here you have to be careful with your algebra, because if my denominator is, say, 6 and 2 pi, that's worth 12. So if you notice, doubling the denominator and subtracting 1 gives you the numerator. 6 times 2 is 12, minus 1 is 11. 4 times 2 is 8, minus 1 is 7. 3 times 2 is 6, minus 1 is 5, because we are one shy from making 2 pi, which is double the denominator. All right, so that's just a couple tips. There are plenty more, so I'd encourage you to Google or look up whatever you need to, but you will be asked to memorize the unit circle. And then with that, I may ask you to sketch a radian measure on a unit circle like you saw on the previous practice set. That kind of goes with the learning objective for the unit circles. All right, and so that's it for the unit circle. In the next piece of this video, or the next objective for this, I will talk about why this is useful. I will copy this down. I've actually already highlighted it, but we'll get into it in the next part.